Yes. Good evening, students. Today's topic is metals and non-metals. Okay. Yes, welcome to Sankalp learning classes. Good evening, everyone. Yes. So today we are studying the topic metals and non-metals. Already you know what is metal and what is non-metal ಅಲ್ವಾ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಮೆಟಲ್ಸ್ ಅಂದ್ರೆ ಏನು ಮೆಟಲ್ಸ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಏನು ನಾನ್ ಮೆಟಲ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಏನು ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಿದೆ. Okay, so let us. Can you give me the example for any metal? Metal ಗೆ example ಕೊಡ್ಬೋದಾ? Anybody? Please write your answer in the comment box. So metals, example for metals. Yes, yes. Iron, then magnesium, Mg we can write. Then copper, yes, somebody. Pallavi, yes, copper. So that is also metal. And can you give the example for non-metals? What are non-metals? So carbon, then sulfur, then iodine. These all are the example for the non-metals, right? Then so let us see the physical properties of the metals. Yes. So aluminum, steel, iron, copper, brass, bronze, and cobalt, chromium, and magnesium, nickel, lead, tin. These all are example for the metals, right? Yes. Let us see the physical properties of the metal. What do you mean by physical properties? Physical properties means the properties that we can observe externally. Okay, so physically we can observe that properties, so they're called as physical properties of the metal. You know that the metal that is hard, right? So that is solid in state. Commonly metals are very hard and they are solid in state, right? So here the first physical properties, metals in their pure state have shining surface, and this property is called as metallic luster. ಸೊ ಲಸ್ಟ್ರಸ್ ನೇಚರ್ ಮೀನ್ಸ್ ಶೈನಿಂಗ್ ಸರ್ಫೇಸ್ ಅಲ್ವಾ. ಸೊ ನೀವು ಕಾಮನ್ ಆಗಿ ಮೆಟಲ್ಸ್ ಅನ್ನ ತೆಗೆದುಕೊಂಡ್ರೆ ಕಾಪರ್ ಇರಬಹುದು, ಅಲ್ಯೂಮಿನಿಯಂ ಇರಬಹುದು, ಐರನ್ ಇರಬಹುದು. ಸೊ ಒಂದು ಈ ಯಾವುದೋ ಒಂದು ಮೆಟಲ್ ಅನ್ನ ತೆಗೆದುಕೊಂಡು ಒಂದು ಸ್ಯಾಂಡ್ ಪೇಪರ್ ಇಂದ ಅದನ್ನ ರಬ್ ಮಾಡಿ, ಸೊ ಆ ಮೆಟಲ್ ಅನ್ನ ರಬ್ ಮಾಡಿದಾಗ ನೀವು ಆ ಒಂದು ಪ್ಯೂರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿರೋ ಮೆಟಲ್ ಆಗಿದ್ರೆ, ಸೊ ನಾಟ್ ಇನ್ ದ ಅದರ್ ಫಾರ್ಮ್, ಪ್ಯೂರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿರೋ ಮೆಟಲ್ ಆಗಿದ್ರೆ, ಸೊ ದ ಮೆಟಲ್ಸ್ ದೇ ಶೋ ಶೈನಿಂಗ್ ನೇಚರ್, ಶೈನಿಂಗ್ ಸರ್ಫೇಸ್. ಸೊ ಶೈನಿಂಗ್ ಸರ್ಫೇಸ್ ಅನ್ನ ನೀವು ನೋಡ್ಬೋದು ಅಲ್ವಾ. ಕಾಮನ್ ಆಗಿ ಕಾಪರ್ ಕೂಡ ಏನಾಗಿರುತ್ತೆ, ಶೈನಿಂಗ್ ನೇಚರ್ ಇದೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಮೆಟಾಲಿಕ್ ಲಸ್ಟರ್. Then metals are generally hard. The hardness varies from metal to metal. So ಕಾಮನ್ ಆಗಿ ನೀವು ಕಾಪರ್ ಇರಬಹುದು, ಐರನ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಇರಬಹುದು, ದೆನ್ ಅಲ್ಯೂಮಿನಿಯಂ, ಕೋಬಾಲ್ಟ್. ಸೊ ವೆನ್ ಯು ಟಚ್ ದಟ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ದೇ ಆರ್ ಜನರಲಿ ಹಾರ್ಡ್, right? So that is the second characteristic feature. So second physical property of the metal. So, and the third property, some metals can be beaten into thin sheets. This property is called as malleability. So, there is an activity given. So, what is that activity? Just take the hammer. So, you have to take the hammer and just beat the some metals, beat the some metals with that hammer. So the metals, they will become thin sheets, right? So the metals, when you uh, beat that metal, the metals, they will become thin sheets, and this property is called as the malleability. Okay, so the some metals can be beaten into thin sheets, and this property is called as the malleability. They have malleability property. Okay, so these three are very important physical properties of the metal. So I hope these 3 points are clear. Metals, they have luster in nature, lustrous nature, and they are very hard, and they beaten into thin sheets, and this property is called as malleability. Okay. So here you can see the metals, they are hard and in solid state. In the first picture, you can see the metals which are in hard and solid state and they are having the shiny nature. Okay. Then next one. So the ability of the metals to be drawn into thin wires is called ductility. So the metals, they are used to make the uh, thin wires, right? So that property is called as ductility. So gold is the more ductile metal. So you know that the metals commonly to make the wires and everything, commonly we use the metals only, right? So what is that property which is helping to help to make the wires? That is nothing but the ductility property. Okay, so ನಾವೇನ್ ಮಾಡಬಹುದು, ಮೆಟಲ್ಸ್ ಅನ್ನ ಮೆಟಲ್ಸ್ ಅನ್ನ ಥಿನ್ ವೈರ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು ಅಲ್ವಾ? ಸೊ ಆ ಒಂದು ಪ್ರಾಪರ್ಟಿನ ಡಕ್ಟಿಲಿಟಿ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ. Then a wire of about 2 kilometer length can be drawn from 1 gram of gold. See here, so we can make the 2 kilometer wire, length of 2 kilometer wire, so from 1 gram of gold. Okay, so that property is called as the ductility. So here you can see the ductility property, alva. So we can make the thin wires, and this is the malleability, thin sheets, and this is the lustrous nature. So that is the shining nature. Okay, so these three are important physical properties of metal. Then next property. So you know that commonly in our kitchen we use metals, right? So some cooking vessels, they are made up of metals. Then which property make the metal that is useful to make them as a vessel? So ಯಾವ ಪ್ರಾಪರ್ಟಿ, ಈಗ ನೀವು ಕಾಮನ್ ಆಗಿ ಕಿಚನ್ ಅಲ್ಲಿ ನೋಡಿರ್ತೀರ ಅಲ್ವಾ? ಕಿಚನ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಿರ್ತೇವೆ ನಾವು, ಮೆಟಲ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿರ್ತೇವೆ ಅಲ್ವಾ? ಸೊ ಮೆಟಲ್ ವೆಸಲ್ಸ್ ಅನ್ನ ಕಾಮನ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿರ್ತೇವೆ. ಸೊ ದಿಸ್ ವೆಸಲ್, ಸೊ ಈ ವೆಸಲ್ ಅನ್ನ ಮಾಡಕ್ಕೆ ಯಾವ ಪ್ರಾಪರ್ಟಿ ಹೆಲ್ಪ್ ಆಗ್ತಾ ಇದೆ ಅಂತ, ವಿಚ್ ಪ್ರಾಪರ್ಟಿ ಈಸ್ ಹೆಲ್ಪಿಂಗ್ ಟು ಮೇಕ್ ದ ವೆಸಲ್ಸ್? ಓಕೆ, ಸೊ ಹಿಯರ್ you can see the one activity is there. Okay, so to prove this point, there is an activity. See here, so there is a stand. So here with the help of clamp, so there is a metal wire is holded here like this. ಒಂದು metal wire ಅನ್ನ ಈ ರೀತಿಯಾಗಿ hold ಮಾಡಿದ್ದಾರೆ. Then that metal wire, so at the end, so it is fixed with one pin. Okay, so there is a pin, so with the help of wax. Okay, so with the help of wax, so the pin is joined there. Then so using the burner, so you have to heat the metal wire, so at near the clamp. Okay, so near here you have to heat this. So what you can observe in this activity, so ನೀವೇನ್ ಮಾಡಬೇಕು, ಒಂದು ಬರ್ನರ್ ಅನ್ನ ತೆಗೆದುಕೊಂಡು ಈ ಒಂದು ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹೀಟ್ ಮಾಡಬೇಕು, ಮೆಟಲ್ ವೈರ್ ಅನ್ನ ಹೀಟ್ ಮಾಡಬೇಕು. ಸೊ ವಾಟ್ ಯು ಸಿ ಇನ್ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್, ನೀವು ಏನನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಾ? ಎಸ್, ಮೆಟಲ್ ಈಸ್ ಗುಡ್ ಕಂಡಕ್ಟರ್ ಆಫ್ ಹೀಟ್. ವೆರಿ ಗುಡ್, ವೆರಿ ಗುಡ್. ಸೊ ಇಲ್ಲಿ ನೀವು ಸ್ವಲ್ಪ ಹೊತ್ತು ಬಿಟ್ಟು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ ಪಿನ್ ದಟ್ ಈಸ್ ಹೀಟೆಡ್, right? So if you touch this end, that is also heated. So what we can observe here, so here you can see the conduction of heat. You have heated the wire here, but the pin joined at one end, that is heated. So here what we can see, good conductor of heat, good conductor of heat, that we can observe here. And one more thing, so if you use the burner also, this metal wire that will not um, melt. Okay, if you use the burner to heat this metal wire also, so it will not melt. ಓಕೆ, ಸೊ ದೀಸ್ ಟೂ ಪಾಯಿಂಟ್ ವಿ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಇನ್ ದಿಸ್ ಆಕ್ಟಿವಿಟಿ. ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲಿ ನಾವು ಮೆಟಲ್ ವೈರ್ ಅನ್ನ ತೆಗೆದುಕೊಂಡಿದ್ದೇವೆ ಅಲ್ವಾ, ಈ ಮೆಟಲ್ ವೈರ್ ಏನಾಗೋದಿಲ್ಲ, ಮೆಲ್ಟ್ ಆಗೋದಿಲ್ಲ. ಹಾಗೆ ಈ ಒಂದು ಪಿನ್ ಏನ್ ಜಾಯಿನ್ ಮಾಡಿದ್ದೇವೆ ಎಂಡ್ ಅಲ್ಲಿ, ಸೊ ದಟ್ ಈಸ್ ಹೀಟೆಡ್. Two points we have observed in this activity. Then how we can conclude this activity? So we can conclude this activity by metals are good conductors of heat and have high melting points. So ಈ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಇರೋದಕ್ಕೆ, ಮೆಟಲ್ಸ್ ಆರ್ ಗುಡ್ ಕಂಡಕ್ಟರ್ಸ್ ಆಫ್ ಹೀಟ್ ಆ್ಯಂಡ್ ಹ್ಯಾವ್ ಹೈ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ಸ್. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಪ್ರಾಪರ್ಟಿ ಕಾಮನ್ಲಿ ಮೆಟಲ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಇನ್ ಕಿಚನ್. ಓಕೆ, ಸೊ ಈ ಒಂದು ಪ್ರಾಪರ್ಟಿ ಇರೋದಕ್ಕೆ ಏನು ಮಾಡ್ತಾರೆ, ಮೆಟಲ್ಸನ್ನು ಕಾಮನ್ ಆಗಿ ಕಿಚನಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಬಿಕಾಸ್ ಟು ಕುಕ್ ದ ಫುಡ್ ಆ್ಯಂಡ್ ವೆನ್ ಯು ಹೀಟೆಡ್ ದಟ್ ವೆಸಲ್, ಸೊ ಇಟ್ ವಿಲ್ ನಾಟ್ ಮೆಲ್ಟ್ ಅಲ್ವಾ. ಸೊ ನಿಮ್ಮ ಕಿಚನ್ನಲ್ಲಿರೋ ಯಾವುದೇ ಒಂದು ವೆಸಲ್ಸ್ ಏನಾಗಿದೆಯಾ, ಮೆಲ್ಟ್ ಆಗಿದೆಯಾ, ಇಲ್ಲ, ಬಿಕಾಸ್ ದೇ ಹ್ಯಾವ್ ಹೈ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಸೊ ಆ್ಯಂಡ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ದ ಬೆಸ್ಟ್ ಕಂಡಕ್ಟರ್ ಆಫ್ ಹೀಟ್ ಆರ್ ಸಿಲ್ವರ್ ಆ್ಯಂಡ್ ಕಾಪರ್. The best conductors of heat are, here you can see, the best conductor of heat are silver and copper. Very very important for your MCQ. The best conductors of heat are silver and the copper. Lead and mercury are comparatively poor conductor of heat. So in metal also we can see the good conductor of heat and poor conductor of heat. So good conductor of heat, that is silver and the copper, and lead and the mercury are the comparatively poor conductor of heat. Okay, so these 2 points that we can observe here. Next point, metals have sonorous property. So what is the meaning of that sonorous property? The metals that produce a sound on striking hard surface are said to be sonorous. ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ನಾವು ಮೆಟಲ್ಸ್ ಅನ್ನ ಒಂದು ಹಾರ್ಡ್ ಸರ್ಫೇಸಿಗೆ ಸ್ಟ್ರೈಕ್ ಮಾಡಿದಾಗ, ವೆನ್ ದೇ ಹಿಟ್ ಇಟ್ ಸ್ಟ್ರಾಂಗ್ಲಿ, ಸೊ ದೇ ಮೇಕ್ ದ ಸೌಂಡ್, ದೇ ಮೇಕ್ ಸಮ್ ಸೌಂಡ್, right? So that is nothing but the sonorous property. Okay, I hope this point is clear. Next one, next important physical property, that is metals are good conductors of heat and electricity. Okay, sorry, metals are good conductors of electricity. You know that commonly to conduct the electricity, you can observe many electronic appliances. So in that appliances you can see the wires that is made up of the mainly metals ಅಲ್ವಾ. ಸೊ ಈ ತರ ಒಂದು ಬ್ಯಾಟ್ರಿ ಇರಬಹುದು ಅಥವಾ ಬೇರೆ ಬೇರೆ ಒಂದು ಅಪ್ಲಿಯನ್ಸಸ್ ಅಲ್ಲಿ ಇರಬಹುದು. ಸೊ ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದ್ಯಾಟ್ ದ ವೈರ್ ದಟ್ ಈಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ದಿ ಮೆಟಲ್. ಓಕೆ, ಸೊ ಬಿಕಾಸ್ ದೇ ಆರ್ good conductors of electricity. So if you set up the circuit like this by using battery, bulb and the switch, when you switch on the insert, so here you can any sample metal you can insert here. Okay, for example, if you insert the copper here, when you switch on the light, the bulb will glow. Okay, so if you use any non-metal, so here you can't see the bulb glowing. Okay, so we can say that metals are good conductors of electricity. So here you can see the wires. So this is the conductor wire. So it may be a metal. It is a metal made up of copper or any other wire. And you can see the color insulated PVC insulation around that wire. So what is the reason behind this? ನೀವು ನೋಡಿರ್ತೀರಲ್ವಾ, ಕಾಮನ್ ಆಗಿ ವೈರ್ ಇರುತ್ತೆ, ಮೆಟಲ್ ವೈರ್ ಇರುತ್ತೆ, ಅದ್ರ ಸುತ್ತ ಏನಿರುತ್ತೆ, ಇನ್ಸುಲೇಷನ್ ಇರುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಇನ್ಸುಲೇಷನ್ you can observe. So what is the reason of this usage of this PVS insulation? Yes, anybody? Yes, so there's previous insulation, so that prevent the uh, that is not a conductor, okay, so which is used around this wire to prevent the electric shock. The person, so he can touch this wire because the PVC insulation that will not allow the current outside, okay, so that is the thing. Yes, electricity should not pass through our body. Yes, that is the correct answer. Then, so these all are the properties of the metals, physical properties of metal. So you can say seven important properties of metal. So the first properties, so they show the metallic luster, that is the shining property, and they are generally solid state, and they are hard, and they can be beaten into thin sheet, that is called as malleability property. And the next one, ductility, then ductility, then so they are good conductor of heat, and they have high melting points. This is the next property. And metals have sonorous property, that is um, the sound, they make the sound when they are strike on the hard surface. Then metals are good conductors of electricity, they conduct the electricity. So these are very important, seven important physical properties of metals. So in your exam, so they will ask write the physical properties of metals, and they will also ask one more question like the metals which show the which are good conductor of heat, and also what is ductility, what is malleability. So these all things they'll ask for 2 mark question, as a 2 mark question, okay. So these physical properties are very very important. Okay, any doubts? Next one, physical properties of non-metals. Okay, so physical properties of non-metals. So what you mean by non-metals? How do you define the non-metals? So you know that sulfur, iodine, oxygen, hydrogen. So these all are example for the non-metals. So the non-metals are either solids or gases except bromine, which is a liquid, okay. So non-metals, how do you define the non-metals? So you can observe, so these all are example for non-metals, okay. So just see, they are not in hard condition, right? So they are not in a, almost not in a solid condition, and some are in a solid condition, some are in a amorphous, means powderous condition also. So what is the difference you find in between the metal and non-metal? Just compare the properties of this important properties, okay. So just take the carbon. Okay, carbon, that is the non-metal. So the surface, that is not a hard surface. Carbon is not having the hard surface. Hardness is, that is very less. Malleability, that is also, so if you take the any non-metal, and if you beat that using hammer, so just they will break down, they will not become into a thin sheet. So metals ಆಗಿದ್ರೆ ಏನಾಗ್ತಿತ್ತು, thin sheet ಆಗ್ತಿತ್ತು ಅಲ್ವಾ, but non-metal, they will not become a thin sheet. They don't have the malleability property, and they don't have the ductility property, and they do not conduct the electricity, and they do not form any sound, okay. Sonority is also not there. But there are some exceptions. So we cannot define this is metal and non-metal by observing the physical properties. So very very important. We cannot decide whether it is a metal or non-metal by using the physical properties. Okay. So we have so many exceptions. Because of that reason, here all metals except, so what are the exception that we can observe in this, so that we are studying now, okay. So here all metals except mercury exist at as solid state at room temperature. So here in metals also, in non-metals also, we can observe some exceptions. Okay, exceptions means they show some other character. So we cannot decide whether it is a metal or non-metal based on the physical property. Okay, so we have to check chemical properties also. So let us see some exception that we observe in metal and non-metal. Here, all metals except mercury exist as solids at room temperature. Okay, so all the metals are solids in state, that I explained. But mercury, that is liquid at the room temperature. Okay, mercury, that is at the liquid state at the room temperature. Then the second one, metals have high melting point. So you know that metals commonly, so this property we have studied. Commonly they have the high melting point, but gallium and the cesium have very low melting point. So they have very low melting point. So low melting point means just these metals, if you keep them on your palm, so they will start to melt. Okay, so that is the very important property. Metals have high melting points, but gallium and cesium, they have very low melting points. That is very very important for your exam. Which of the following, they will ask in the MCQ, which of the following, which have very metals commonly have high melting point, which of the following have the low melting point. Okay, so that is the thing. Next point, iodine is non-metal but it is lustrous in nature. You know that metals commonly they show the commonly they have the lustrous property, shining property. But here we can see that iodine, which is the non-metal but it is lustrous in nature. Okay, lustrous means that is having the shining surface. Okay, that is the thing. And carbon is a non-metal that can exist in a different forms. Each form is called as the allotrope. Okay, carbon that is found in the different form, so that form is called as the allotrope. What is allotrope also they will ask. And diamond is an allotrope of the carbon. It is the hardest natural substance known as very high melting point and boiling point. But diamond is, so that is made up of carbon, right? That is the allotrope of the carbon. And this diamond, that is the non-metal. Diamond is the non-metal, but it is having the, that is the hardest substance. Okay, and has very high melting and boiling point. So the graphite, another allotrope of carbon, it is a conductor of electricity. Graphite which conduct the electricity. Okay, so that is the very important thing about this non-metal. So diamond and graphite, diamond and graphite, they are the allotrope of the carbon. But here this diamond is the non-metal, but that is the hardest natural substance which have the high melting point and the boiling point, very important. And graphite which conduct the electricity, it is the non-metal but still it conduct the electricity. Okay, so this is very important thing that you have to learn. Okay, I hope these points are clear. Next one, alkali metals like lithium, sodium, and potassium. Okay, so note down this: lithium, sodium, and potassium are so soft that they can be cut with knife, and they have low densities and low melting points. So these are metals. Instead of metals, they are very soft. Okay, they can be cut with the knife. So if we take the iron, copper, and other metal, so we cannot cut with it with knife, right? But here they have low densities and low melting points. So that is very important. Okay, So that is about the exceptions, that why we cannot consider physical properties of these metals and non-metals to classify whether it is a metal or non-metal. Okay, so we won't use that physical properties, we use only chemical properties. Okay, so let us move to the next slide. So elements can be more clearly classified as metals or non-metals on the basis of their chemical properties. Okay, so now what we have studied, that is the physical properties of the metals and the exceptions. So why these elements are not classified by using the physical properties. Okay, so exceptions that we have studied. Now let us see the chemical properties. Before going to start the chemical properties, some questions are there. Let us solve these questions. Give an example for metal which liquid at room temperature. Can you comment your answer? The metal which is liquid at room temperature. Yes, anybody please comment the answer. Yes, mercury. Vijay Lakshmi D. Yes, mercury is the metal which is liquid at room temperature. Okay, then can be the metal which can be easily cut with knife. Yes. Second one, what is the answer for the second one? What is the answer for second one? Dear students, don't chat unnecessarily in the comment box. If you have, yes, sodium, lithium. Yes, very good. Many students are writing the answer. Sodium and lithium, so that we can cut with the knife. Which is the best conductor of heat? Which is the best conductor of heat? Lithium, sodium, potassium. Yes, very good. Next one, silver. Yes, Vijay Lakshmi, very good. Silver is the good conductor of heat. And the last one, which is the poor conductor of heat? Poor conductor of heat. Which metal is the poor conductor of heat? Not graphite. Okay, best conductor of it is silver. Graphite, that is the non-metal that also conduct the electricity. Okay, that is not a good conductor of it. Yes, what is the answer for the fourth one? Yes, lead. Lead is the poor conductor of heat. Yes, very good. Not plastic. Okay, metals I'm asking. Second question, explain the meanings of malleable and ductile. So malleability means the metals that can be beaten into thin sheets. That property is called as malleable, and ductile means they can be which we can make into wires. So that is called as the ductility. Okay, yes, very good. Then let us move to the next chemical properties of the metal. So in that first one, when metal burns with air, okay, what happens when metal burns with air? So you know that if you take any metal, for example, magnesium or copper or any metal, so when it burns with air means oxygen is there in air. So what it forms, so that we have to find out, that is the chemical property. Okay, so here almost all the metals combine with oxygen to form the metal oxide. So when the metals combines with the, when it is heated, when it is burned in air means oxygen is present in the air and they form the metal oxide. Okay, let us see the example for this. Yes, here copper is heated in air and combines with the oxygen and form the copper oxide, a black color oxide. Okay, here we have taken the example as the copper that is heated with the oxygen present in the air and which form the copper oxide. Okay, copper oxide is formed. So that is the black color oxide. Commonly they form the metal oxides. Okay, so that is the correct answer. Second one, similarly, aluminium forms aluminium oxide. Okay, so when the aluminium is heated in the air, so which forms the aluminium oxide? So aluminium 4Al plus oxygen means which is present in the air, which forms the aluminium oxide. Very important. So they will give the definition like aluminium forms the aluminium oxide when it is heated with the when it's burned with the air. Okay, so these examples are very important. So examples, please practice the examples. So first one is the copper and the second one is the aluminium. Okay, next one. Some metal oxides such as aluminium oxide, zinc oxide show both acidic as well as basic behavior. So these are called as amphoteric oxides, right? So some such metal oxides react with the both acids as well as base and produce the salt and water. They are known as amphoteric oxides. So I hope you have studied about the amphoteric oxides. Aluminium oxide reacts in the following manner with the acids and bases. Amphoteric oxides means the metal oxides which react with both acids as well as bases to produce a salt and water. The metal which react with acid also and base also. Okay. And here reaction with such amphoteric oxides. The reaction with the metals, metal oxides like amphoteric oxides. So they form the, when they react with the hydrochloric acid, they form the aluminium chloride and water. When this aluminium oxide that react with the sodium hydroxide, that forms the sodium aluminate. So this is the sodium aluminate. Okay, so that is the reaction. When the amphoteric oxides, they react with both acids and bases. So they produces the salt and water. So here you can see the salt and water. So they will give like this. The amphoteric oxide which react with the acids and bases, what they will form? They form salt and water. When they react with the base also, they form the salt and water. Okay, so that is the answer. Please note down this one. This is very important for your exam. Next one. Most metal oxides are insoluble in water, but some of them dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to produce the alkalis as follows. See here, most of the metal oxides, they are insoluble. For example, sodium oxide, potassium oxide. So they are insoluble, but when they dissolve in water, when they react with water, again they form the alkalis like sodium hydroxide and potassium hydroxide. So how you can conclude? Metal oxides react with water and form the, what they will form? They form the alkalis. They form the alkalis. Okay, so that is the. Then different metals show different activities towards the oxygen. So some metals, they'll show the different activity towards the oxygen. So see here, Metals such as potassium and sodium react vigorously that they catch fire if they get kept open. So this is very important, very, very important. So what happens when highly reactive metals like sodium, potassium, when they react with oxygen present in the air? So they vigorously catch the fire, and they can cause anything to the user. So hence, to protect them and to prevent accidental fires, they are kept immersed in kerosene. Why potassium and sodium they kept in a kerosene or immersed in kerosene? What is the reason? Give reason question. Very important. Yes. So why potassium and sodium they kept in kerosene? Because so they may catch the fire vigorously. They react with the atmospheric oxygen and they catch the fire. So that is the reason behind this. Okay. So, at ordinary temperature, the surfaces of metals such as magnesium, aluminium, and zinc lead are covered with thin layer of oxide. They protect the oxide layer, the protective oxide layer prevents the metal from the further oxidation. So, if you see the iron or zinc, aluminium metals, so just imagine this is the metal and the outer layer that is covered by the oxide. Okay, because the metal react with the, just imagine this is the outer layer that is made up of the oxide layer, and this oxide layer that prevent the remaining metal from the further oxidation, which prevent the further oxidation. Okay, and iron does not burn on heating, but iron fillings burn vigorously when they sprinkled in the flame of burner. And one more thing, copper does not burn, but the hot metal is coated with the black colored layer that is called as copper oxide. Copper also does not burn, but they will form some other form. The metal that forms the some other form that is called as the copper oxide. Okay. So that is the answer. And silver and gold do not react with oxygen even at the high temperature. So this is very important. The metals which do not react with uh, the metal which do not react with the oxygen. Okay, that is silver and gold. Very, very important. And the black color coat that is formed around the copper, that is the copper oxide. That is very important. That is the copper oxide. Okay, so these all are important things. So that is related to the how the metals react with the oxygen or sodium is the most reactive of the samples metal taken here, and the reaction of magnesium is less vigorous, implying that it is not reactive as sodium. Okay, sodium is highly reactive and magnesium is less reactive. But burning in oxygen does not help us to decide the reactivity of zinc, iron, and copper or the lead. So this is the important thing so that we learned about the what? The metals reaction with air when the metal burns with air. So they form the commonly they form the metal oxide. So these are the two example which form the metal oxide, aluminium and the copper. Then so some other metals, how they are going to react with the atmospheric oxygen. Okay, so this is one thing, and the second thing is how the oxides, sodium oxides or potassium oxides, how they, when they dissolve in water, they form the alkalis. So this is also important reaction. Then why potassium and sodium they kept immersed in kerosene oil. So this is also important thing. Okay. So let us move to the next chemical property, metals reaction with water. What happens when the metals react with the water? Okay. Here, metals react with water to form metal oxides or metal hydroxide and the hydrogen. See here, when the metals, so just imagine copper, it react with the water. Is it react with the water? So let us see. Here, commonly, when the metals react with water to form metal oxides or metal hydroxide and the hydrogen. Okay, so that is the answer. But so there is a activity for this. So there is a activity. You have to take the three test tube. Okay. So here, so I will take some metal plus cold water. Okay. Cold water, then hot water, some metal samples plus hot water, then some metal samples with steam. Okay, some metal samples with steam. So some metals they react with the cold water and some metals they react with the hot water and some metals they react with the steam. So the changes that we can observe in the metals. So let us study the reactions. Okay. So this is the experimental setup. So how the metals react with the steam. Okay. So let us see, this diagram is very important. Let us see the metals react with water and produce a metal oxide and gas, that you know. Metal oxides that are soluble in water dissolve in it and to further form metal hydroxide, but all the metals do not react with water. Okay, so here you can see metal plus water, so which form the metal oxide. So when this metal oxide react with water, which form the metal hydroxide and the hydrogen. Okay. So this happens when the metal oxide that is react with the water. Then metals like potassium and sodium react with cold water violently. With case of sodium and potassium, the reaction is so violent and the exothermic, so that they evolved hydrogen immediately catches the fire. See here, when the sodium and potassium so react with the cold water, so the reaction is exothermic. What is the meaning of exothermic reaction? Can you write the meaning of exothermic reaction? What happens in the exothermic reaction? Anybody? Yes. What happens in the exothermic reaction? Yes, anybody? Okay, so exothermic reaction means lot of heat released in the reaction, that is called as the exothermic reaction. Okay, so when the metals react with cold water, that is the exothermic and vigorous reaction takes place, and the hydrogen release that catches the fire. Okay, so that is the thing. And here when the potassium react with the water, they form the potassium hydroxide and the hydrogen. They release lot of heat energy, and the hydrogen that catches the fire, and sodium and water that form the sodium hydroxide and the hydrogen, and lot of heat energy is released, hence it is called as the exothermic reaction. Okay, so very important reaction, please note down these two reaction. When the potassium and the uh, sodium react with water, so they form the hydroxides and they release the hydrogen, and the hydrogen that catches the fire immediately. Okay, then the reaction of calcium with water is less violent. So here potassium and sodium reaction is, that is violent, but it is less violent. So here calcium react with the water, which forms the calcium hydroxide and the hydrogen. So here calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Okay, so the calcium starts floating because the bubbles that is formed, hydrogen gas bubble, so that stick to the surface of the metal. Okay, so this reaction is very important, calcium reaction with the water, calcium hydroxide and the hydrogen. Then see here the very important thing, the magnesium which does not react with the cold water, it react with hot water to form the magnesium hydroxide and the hydrogen. So the metal which react with the hot water, that is the magnesium. Okay, magnesium, so that react with hot water. It also starts floating due to the bubbles of hydrogen and gas sticking to its surface. Okay, and metals like aluminium, iron, zinc do not react with the cold water. So some metals, I told in the starting only, some metals they react with the water and some cold water, some they react with the hot water and some they react with the steam only. So here this zinc and iron, they do not react with the cold or hot water, but they react with the steam and form the metal oxide and the hydrogen. The thing is, uh, if they react with the steam also, they form the hydrogen oxide, they form the metal oxide and the hydrogen. Okay, so here you can see aluminium that reacts with the water, so that is steam. Okay, here it is given gaseous form and forms the aluminium oxide and the hydrogen gas. So iron that reacts with the steam, H2O means that is in a steam form. Here we use not in a liquid, that is the gaseous form. It forms the ferrous oxide and the hydrogen gas. Okay, iron reacts with the water and it forms the iron oxide and the hydrogen gas. So that is very important. So how we can conclude this? When the when the metals react with the hot water, cold water or steam, they form the metal oxide and the hydrogen. So in some case, the hydrogen gas, it catches the fire. So due to its amount. Okay, so that is the thing. And some metals, ಕೆಲವೊಂದು metals ಏನಾಗಲ್ಲ ಅಂದ್ರೆ, so the metals such as lead, copper, silver and gold do not react with water at all. So in these three types of water also, cold water, hot water and steam, they do not react with these all things. Okay, copper, lead, silver and gold, they do not react with these all. So that is the very important thing, important for your MCQ. Okay, MCQ ge important ಇದೆ. Okay. What is the boiling point of diamond? Okay, I will check it once. What is the boiling point of what you said? Diamond. I will tell in the next class. Okay. What is the boiling point? So the highest boiling point, I think I will check it once and say in the next class. Okay. Next one. Metals reaction with acids. So how metals are going to react with the acids? So in the second chapter we studied that acids, how they are going to react with the metals, right? So you know that, so when the dilute hydrochloric acids react with these all metals, so let us write zinc, Zn, Zn react with the, just write the equation Zn react with the HCl. So which form? ZnCl2, zinc chloride plus which forms the hydrogen gas. So salt H2, salt and hydrogen gas is released, right? So they form the salt and hydrogen gas. And here also iron Fe react with the HCl. So which forms the FeCl2 plus hydrogen gas. Aluminium Al react with the HCl. So which forms AlCl3, aluminium chloride. So like this, they form the salt and hydrogen gas. Okay. So see here, hydrogen gas is not evolved when the metal react with the nitric acid. So HNO3 is also acid. HNO3 is also acid, but the nitric acid, so that is the nitric acid, the when the metal reacts with the HNO3, the hydrogen gas is not evolved. So what is the reason? Give reason. Question ನಲ್ಲಿ ಇದನ್ನ ಕೇಳ್ತಾರೆ. Hydrogen gas is not evolved when the metal reacts with the nitric acid. ಈ question ಅನ್ನ ಕೇಳ್ತಾರೆ. So it is because HNO3 is strong oxidizing agent. HNO3 ಏನ್ ಮಾಡುತ್ತೆ, ರಿಲೀಸ್ ಆಗಿರುವಂತ ಹೈಡ್ರೋಜನ್ ಅನ್ನ, so it oxidize the hydrogen produced to ವಾಟರ್. ಓಕೆ. ಸೊ ಹೈಡ್ರೋಜನ್ ಅನ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡಿ ವಾಟರ್ ಅನ್ನ ಫಾರ್ಮೇಶನ್ ಮಾಡುತ್ತೆ. ಸೊ get reduced to any of the nitrogen oxide, that is N2O, NO or NO2. ಸೊ ಈ ರೀತಿಯಾಗಿ ಏನಾಗುತ್ತೆ, ಅದು ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಮೆಗ್ನೀಷಿಯಮ್ ಅಂಡ್ ಮ್ಯಾಂಗನೀಸ್ ರಿಯಾಕ್ಟ್ ವಿತ್ very dilute HNO3 and to evolve the H2 gas. So dilute HNO3, if the metals like magnesium and manganese, they react with the dilute HNO3, they evolve the H2 gas. But concentrated HNO3, so which do not, when the metals react with the HNO3, so concentrated if you take, so they do not release the hydrogen gas. Okay. So that is the answer. Very important. So rate of formation of bubbles was the fastest in the case of magnesium. The reaction was also most exothermic in the case. So ಇಲ್ಲಿ ನಾವು reactivity basis ಅನ್ನ ಏನು ಹೇಳ್ಬಹುದು, magnesium, aluminum, zinc and ferrous, like that we can say. But based on the this reactivity, so based on this what you say bubble formation, we cannot write the reactivity. So in the case of copper, no bubbles were seen and the temperature also remain unchanged. This shows the copper does not react with dilute HCl. Okay. So this is how the metals are going to react with the acids. Okay. Very important. These all reactions are very important. Please practice all the reactions. Okay. So what we have studied in today's class, physical properties of metal, very important for your exam. 5 mark or 4 mark question it is. Okay. And chemical properties, the reactions what we have studied, how the metal react with the air, how the metal react with the water, and the reaction of metals with the as here the reaction of metals with the water. So these all things are very important, and this diagram, that is very important for your exam. Okay. So if you have any doubts, you can ask. Otherwise I will continue the next part in the next class. Okay. Yes, if you have any doubts. Okay. Thank you, dear students. Thank you. We'll continue in the next class.